Anyone have any homework questions for me? Because you do have chapter 1 that is due Wednesday, right? This coming Wednesday, chapter 1, 1, 1, 2, 1, 3 is due on Wednesday midnight. And Casey just brought up about rounding. So the online homework will tell you how many decimal places you need to round, 2 or 3 or 4. So you must follow that, what they want. But for my test, it's up to you. 2 or 3 is fine for my test. But for the online homework, they're very strict and very picky with it. So you have to follow what they want. So if you did not round what they asked for, you will probably get it wrong. So just want to point out to you with the online homework here. Anyone have any questions for me with chapter 1 homework?
Yeah, I have question on 1.114. I think
1.1 what again?
14.
14, okay.
Question 14. I think I emailed it to you.
Oh, yep. So I'm going to talk about that. Very good. Yep. And if you have more, just you can either type in the chat room. Okay. So this is 1.1 question 14. It's a little bit different from your question. So because it's everyone has a little bit different. So this question is asking us that we have 7 group of subjects, and each a research was criticized for forcing among the data. They got 7 group of subjects with 5 individual subjects in each group. Okay. So the values are given in percentages of success of each group is this. What's wrong with the value? So what happened is that, so we have, so let's say they got 7 groups of subjects. So every single one of this will have 7. So they break it into 7 groups. 1, 2, 3, 4, 5, 6, and 7. And each group of this, they have 5 people. So 5 people per groups. Okay. And then they want to ask, you know, something with you know, how many what is the percentage of success on each group. So if they only have 5 people and the result came out to be like this, 53%, 58%, 63%, and so on, right? They give you all the percentages that, and they say all these percentages are wrong. They give all these percentages, all these percentages are wrong. Why it is all wrong? And that's why the question is. So since everyone here has only 5 people in a group, so my question to you is, if we only got no people, this is 0%, right? If you only got 1 people, how many percent is this? Out of 5, right? So what's 1 out of 5? That is only 20%, right? And 2 people is 2 out of 5, 40%. 3 people, 3 out of 5, which is 60%. And then 4 will be 80%. And if all 5 say yes, it's 100%. So what can you tell here is these percentages can only be 0, 20, 40, 60, 80, 100. It cannot be 53 or 58 or 50, whatever these percentages are. The reason why is because you only have 5 people in a group. So that means if 1 say yes, 20%. If 2 say yes, 40%. Or 3 say yes, 60%. So you cannot have this because all these percentages should be what? Multiples of 20, multiples of 7, multiples of 5, or multiples of 10. What do you think about this one? If you look at all these percentages, they all should be multiples of
20.
So that's the reason why that the percentages here are wrong, is because it should be multiples of 10, 20 in this case, because there are only 5 people in a group. So you can only get 0, 20, 40, 60, 80, 100%. You cannot go with these weird numbers here. You okay there?
Yes, thank you.
Anyone have any questions for me beside this one? All right. So if you do, you can stay up after class a little bit because today we'll talk about 2-1. And if we can, we do 2-2 a little bit. The reason why is because that we don't have class on Wednesday. So don't come to the school at all for my class. Okay, just only my class. Your other class have class on Wednesday, just for me. So on Wednesday we don't have class, and then don't forget that on Monday is a holiday because it's a Labor Day weekend. So actually, I won't see you guys till next Wednesday, which is like 10 days from today, around 9-10 days from today. So make sure you guys, if you have any questions, make sure you email me. 2-1 and 2-2 is the homework that is due on next Wednesday. So we will try to do 2-1 for sure. And then 2-2, I will try my best to see if I can teach you guys because 2-2 is not a lot of stuff. 2-1 is a bit and involve a little bit of math here. So that's the reason why that I need to teach 2-1 a bit more. 2-2 is mostly is how we read the graph. So that one, and then when you come back on Wednesday, not the following Wednesday. So if you have any questions, we'll talk about it because we still have a few more because that is the homework due on that day. So let's talk about 2.1 here. So in chapter 1, you learn about all the what we call as the basic stuff of statistics, how we got data, what's the best way to get data, get the sample, the sampling methods and all those things. What is bias, what is not bias, what is considered, what kind of variables you have, like categorical and quantitative and all those type. So once you got the data, your data is what we call as a raw data. So raw data is like all icky data that you do not want to see. For example, is like if you look at your StatCrunch, if you look at the data set that you get from your textbook, the one that I showed you, like body data. So this is what we call as raw data. So you do not, everyone do not want to see this kind of data because, who wants to look at all these 300 data here? So what we do here is once you got the raw data, so chapter 2 comes in. So once we do chapter 2, we begin to what we call as summarizing this data. And there are 2 ways for us to summarize. One is draw a table. We call that as a frequency distribution, and then the other way is to graph it. So to summarize this data, we got 2 ways, tables, which is you learn in 2.1, and graphing, 2.2 and 2.3. Those are 2 sections we talk about how we graph. I just want to point out to you guys that you do not need to know how to graph like a pie chart, and it means you do not need to take a protractor and draw a circle and measuring all the angles. You do not need to do that because in the test, I won't call you to draw the graphs. So in the test, I will provide the graph. You just need to tell me how to read the graph. Okay, Nadia, this Wednesday, yes, we don't have school. So for me, you don't have school. So don't come to the campus because we don't meet on this Wednesday. But your other class, if you have any classes that is on Wednesday, you have class. Only me, I have some personal stuff to do. So this Wednesday you don't show up. And don't forget, Monday is a holiday. Okay. So every time when you back to the notes here. So every time when you guys got your data, once you put inside a table or a graph, there are 5 things you need to talk about characteristic here. The first characteristic we talk about here is what we call as the CVDO. So every time when you do talk about data here, we talk about these 5 characteristics. C stands for center, V stands for variation, D is distribution, O is outliers, and T is time. So this is a CVDO. So what is center means? Center in this case represented by the middle of the data. So for example of the center that you're going to talk about here is like mean, median, mode, mid-range. And I think some of you know as mean and median and mode and mid-range, but if you do not know what are those, do not worry about that. You will learn this in 3.1. So in the next chapter, chapter 3, you will learn about the mean, median, mode, and mid-range. So that is represented by the center, C. Variation is talking about how much the data values vary. So that means what is the, we call it sometimes the range. So how far is from the low to the high, the range. The standard deviation. So those are the standard and variance And the last one is called IQR. So IQR, I'll just put it up here. Since I'm not here. IQR in this case, it stands for interquartile range. Again, these are range, probably you know what it is, but standard deviation, variance, and IQR are pretty new to mostly all of you. You will learn this in 3.2. So again, do not worry about all these fancy words that I'm using here. That means what you need to know is those are means variation. We call variation in statistics. So again, you will learn this in 3.2. Distribution is talking about what kind of shape of it. So one is the middle, one is the how much it varies, the shape. The shape in this case means if you look at the graph, usually we talk about is the shape is going to be like bell shape, uniform, skew. When you talk about skew, it can be skew left or it is skew right. And this distribution, you will learn this in 2.2. So hopefully today I will cover that skewness in this case. So there are quite a few distributions, but we'll mostly concentrate on this 3 or 4 3 bell shape, uniform, skew. Outliers means that if there is any data that lies far away from the rest of the data. So this you will learn in 3.3. Okay, some of you know what is outliers. So if I give you a graph, if the points are really, really far away from the rest of the group, those are outliers. But in 3.3, we will actually show you how to calculate those. So usually if you draw it on the graph, they automatically calculate for you. They just you kind of eyeball it. It's like really, really on the far right or very far left of the rest of the data. The last one we talk about is time, T. This is only happens when your data has changing over time. So mostly your data that we study here doesn't go over time. So we do not look at the time in this case. So we don't do this in our class. Very seldom we have a data that has time. So example is if you look at your data here, so you can tell there's no time over time. So if it's over time, it will be like temperature. It'll be like temperature, it'll be like stock exchange. That means that the value of something will change based on time. So every minute or every hour, it will change. Your gas price will change based on time. So those are the one that if you talk about those, then yes, then the time will be the one something we talk about. So in this case, we did not cover this in my class. So actually, you do not need to cover the T, you just need to do the CBDO. So in the test, usually I do want you guys to, that's a big word, interpret the histogram, or sometimes I say interpret the data and in the test. And I always ask you for 4 points. And this, what are the 4 points you need to give to me is CBDO. Every one of these worth a point. So center, variation, distribution, outliers. I will teach you how to do this in chapter 2 and chapter 3. So don't worry about, this is just a beginning of it. So don't get shocked about how we do this. You will learn this hopefully by next week, okay? So on this 2.1 is what we call as a frequency distribution. So this is, or sometimes we call it frequency table. This is usually is done by looking at the number of the categories that we have or classes along with the numbers. And this number is what we call as the frequency. Okay, so usually this is done in class a lot. How do we do a frequency distribution? So you always have classes. So usually it's a table form. And usually this is the context. So example will be like, it can be categorical, it can be quantitative. So let's talk about categorical variable here. So we can talk about like eye count. And usually the other one is a frequency. So this is what we call as a frequency distribution. And when I talk about eye color, we got brown, we got blue, we got, green, hazel, right? Green, hazel, I'm sure. So then I just ask, again, I don't have time to ask you guys, just like, how many of you guys are brown eye color? And then you just raise your hand and then I count how many of you guys. So we got 15 of you guys are brown and 10 of you guys are blue and then 3 green, and 2 hazel. Example. So this is what we call as a frequency distribution or frequency table based on a categorical variable on eye color. Okay, so you just raise your hand and that's what we do. So this is called a frequency. That means how many of you belongs to each these classes or these categories. It can be also done by doing quantitative. So we can use quantitative variable, especially with the discrete type. So discrete means the number that you give it to me is either 0, 1, 2, 3, 4, 5, means you cannot have decimals. For example, is number of. So maybe number of TV you have in your house. So it can be 0, no TV in your house. 1, 2, 3, 4. Let's say that I ask you guys, how many TVs do you guys have in your house? And because usually in the classroom, you guys raise your hand, all right? 1, 2, 3, 4, and so on. Let's say that the most one student says he got or she got 7 TVs in her home. Okay, she got 7 TVs. Then I asked how many of you got more than 7 TVs, and no one say anything because she's the one that have the most TV. So when you put down the numbers, you have to go all the way till 7 to the maximum. Okay, 7 TVs. And then I asked, how many of you have no TVs in the home? Raise your hand. And then, oh, there are one of you guys that doesn't have TVs at home. No TVs. And how many have one? Maybe 10 of you guys have 1 TV at home. And 7 have 2 TVs at home. 5 have 3 TVs at home, and 2 has 4 TVs. And then when I ask how many of you have 5 TVs at home, and there is no one has it, so I had to put a 0 in there. So I cannot skip. Some students say, can I skip 5 because since there's no one has 5 TVs? Unfortunately, you cannot skip 5 because there are 6, there are 1 student, and 7, I got 1 student. So like if you have no TVs, you cannot skip, but 7 is a maximum. So you stop, you don't need to continue. So usually when you do a frequency distribution, you always stop at the maximum of the new numbers that you have. So you do not need to go 8, 9, 10, 11, 12 because there's no one has that number. 7 is a maximum you have. So although anyone from 0 to 7, you don't have it, like number 5 TVs, no one has it, you have to put a 0 inside. So this is a frequency distribution for what we call as a quantitative variable that is discrete. And we also can have a quantitative variable for a continuous case. For example, will be your height and your weight. Means that a continuous case means is your it can be decimals, okay, like test score and those. So mostly those are what we call as a continuous case. So I do not want to just figure out, oh, let me see who is the shortest one in this class. Let's say the shortest one in this case is 48 inches, for example. And the tallest one in the class, let's say, is 72 inches. I do not want to put 48, 49, 50, 51, all the way to 72. The reason why is because there's quite a few zeros in here because not everyone has not all these numbers has a representation of it. So we don't want to do this because there's a lot of, some of them have zeros involved. And then, so what do we do here is we put them have what we call as a limit. Okay, so what I mean by we have a limit in this case is, this is usually what we do. So let's say that we have 48 inches is the minimum. This is your minimum. That means the smallest one. And the maximum in this case is 72 inches. Again, this is all example. Because in the class, if we did it in the class, then I have time to collect data from you guys. So I want to say that the width in this case is going to be 5. And what is meaning when I say the width in this case is 5 inches means that every class in this case will represent by 5 numbers. So a lot of students make this mistake in your homework or in the test is, oh, 5. So that means you start with 48. And then you add 5. What is 48 plus 5? 53. So this is 48 to 53. And then you do 54 and then you plus 5 because every one of this is 5. So you add 5, this is 59. And then you go all the way to 672. So 60 to add 5, 65. 66 plus 5 is 71. And don't forget, because the highest is 72, you do need to create a 72 plus 5 is 77. And after that, you just count how many of you guys in this group, right? In this classes, and then you tally them out. Oh, you count them, but raise your hand, right? Unfortunately, when you do this, whatever you calculate is all gonna be wrong. Okay, so don't do this in my homework and in my test. You will not get full points because it has a domino effect here, means that if this is wrong, if beginning is wrong, everything at the end is gonna be wrong. So why is considered wrong is because these numbers that you see here, they are all wrong. These are all wrong numbers. So don't do this in my test. Okay, so when I say the width in this case is 5, don't read across like that 48 plus 5 and so on. Don't do this, it's all going to be wrong. So what is the best way to do it, the correct way to do it? Let's say this is height and this is frequency. And let's say you did start on 48. Now you did add 5, but the 53 that you get, 48 plus 5, 53, you don't put 53 on over there, you on the right next to it, you put the 53 below it. You guys with me here? You guys got what I'm saying? So you see the difference between this one is that this is the correct way to do it. This is the wrong way to do it. Okay. Can someone tell me what is 53 plus another 5? 58, right?
Yeah.
You put it underneath it, plus another 5. 63, right? Plus another 5. 68. Oh, 63, 68, yep. Plus another 5, 73. Now we stop 73 because the highest one is 72. Oh, we don't need this one because so we do not need the last one because the highest one is 72. So you do not need 73 and so on. So now, so when you do the, this is called the frequency distribution with limits. So when you have a width of 5, you add down here, you don't add, put it across. If you put it across, you will get it wrong, okay? Then what you need to do is you have to figure out what is the range of this number. So 48 to what? Now, I just want to point out to you that you cannot put 53 here, because 53 is already used down here. So that is what we call as an overlapping classes. So you have to do a number before 53. So what number is before 53? That will be 52. Like then, so this one is 58. So the number before 58 is 57. This is 63, so the number before 63 is 62. Before 68 is 67. Can someone guess what is this number is? Do you see a pattern on the green one? What can you tell between 52, 57, 62, 67? They all have what?
5 difference.
5 difference. That means your class width is 5. So that means the next one will be 72. That's the class width in this case. So so the correct way for you guys to do this is subtract the 2 classes here. The differences should be the same as the class width. If you see this, what is the difference between 48 and 54? The difference here is 6, right? The difference here is also 6, 54 to 60, and the difference between 53 and 59 is also 6. That's the reason why that this is all wrong, is because the difference here should be 5, not 6, because the width here is 5. Okay. Usually this is given in the question. So some of you ask me, how did we know it's 5 or 6 or 10? Or is you have to read the question, and the question will tell you the class width is 5 or 10 or 6 or whatever number they want you to do. And then the next thing here, you just need to tally them up. So how many of you is from 48 to 52 inches high? And then count, that's 4 of you guys, and 53, there's 8 of you, and then this is just an example. 5 of you, and then 3 of you, and then 2. This is just an example. I'm just telling you. So this is also a frequency distribution. So we got 3 types of frequency distribution. One is for the categorical variables, where you just use like brown, blue, eye color, female, male, Republican, Democrat, independents, others. Those are categorical variables here. And then we also have a discrete type quantitative, where this is counting numbers 0, 1, 2, 3, 4, 5, 6, 7. And then we have the continuous type, where you will get like height and weight. And usually the continuous type has what we call as class limits. It's called class limits. They have a range of numbers here. And if you really count 48 to 52, you got actually 5 numbers in there: 48, 49, 50, 51, 52. There are 5 numbers. That's why the class width is 5. And if you go 53 to 57, 53, 54, 55, 56, 57, there are also 5. So that's the reason why that you have to watch carefully with this. A lot of students make mistake is the one that I cross out in grade here. So do not do this in your tests. You guys with me? You guys, questions so far with this? Okay. So we have names. So now you go some little terms here. So what is the lower class limit? Lower class limit is the one in purple. So 48, 53, 58, 60. This one is called a lower class limit. Okay. The upper class limit is the one in green, the one that goes the other. So one is lower and the one is upper class. Then we have what we call as class boundaries. Okay. So what is class boundary? So class boundary in this case is a number that separate the classes without any gaps to create. So there is no so these terms, this lower class, upper class, class boundary, midpoints, and width only happens when you have this kind of frequency distribution. So if you have like a categorical type or a discrete type, we don't have an upper class, we don't have a lower class, we don't have a boundary, we don't have all this over here. Okay, the only upper lower class and the boundary is only happens when you have a range of numbers like this. Then you can figure out those. So how do we, what is a class boundary? So this is very important, so pay attention, and this is in your midterm. So so what is the class boundary in this case? Is your class boundary is taking the lower of the second class plus the upper of the first class divided by 2. So this is how you find your class boundary. So so what I mean here is lower of the second class, which is 53, and the upper of the first class, which is 52. So these 2 numbers, you add them up and divide it by 2. So 52 plus 53 divided by 2. And what you get? What's the in between 52 and 53? What number is between that? Anyone? Calculators? What's the number between 52 and 53? 52.5, right? Okay. Again, class, I haven't talked about attendance yet. Please don't put attendance there. But the class boundary in this case is not just one. You have to keep on doing it. Means you have to keep on doing the next one. So this is actually for this class. So this is 52.5. So you have to create another one, and another one, you continue working on it. 57 with 58. So what is the middle? Or if you add these 2 up and divide by 2, you will get 57.5. 57 plus 58, and then this is for the and then you have to continue 62 and 63. So if you add them up and divide it by 2, this is 62.5. And then you do the same thing with 67 and 68. This is 67.5. Now, can you guys look at this class boundary? What do you see a pattern coming up? 52.5, 57.5, 62.5. What do you see here? What's the difference?
Goes up by 5 each time.
It's also by 5 by the class. So this is also another way to figure out if you got your answer, your table is correct. Your boundaries will have also the same. If you find a difference, they always match with what the width is. In this case, 5. Now, so pay attention here. So the class boundary here is not just 1, 2, 3, 4. These 4 numbers. It actually has a class boundary 1 before it. And you also have a class boundary that is 1 above it. Okay, so a lot of students, when you talk about like Minnesota, can someone tell me what is the state that that is boundary with Minnesota? So someone will tell, oh, it's Dakotas, Iowa, you know, and Wisconsin. But don't forget, you also need to figure out that there is Canada up here, right? So this boundary is what we're talking about. This is this 2 little friend. So we do have a class boundary that is before that, and we have a class boundary after that. So can someone tell me how you figure out these 2 boundary points? As you know, they are all difference of 5s, right? So how do you figure out these boundary points? The first, we call it the first class boundary. So you take what?
48 and 72.
48 and what?
72.
42 should be 47, right? So what is the middle between 47 and 48? That should be 47.5. Is that a difference of 5? 47.5 to 52.5? Yes. And how do we find the last one? It's between 72 and what? 73. So this is going to be what? 72.5. So so this is something I want to tell everyone about. This is if you look at the frequency distribution we have here, we got 1, 2, 3, 4, 5. You have 5 classes here. So in this example, we have 5 classes. You got 1, 2, 3, 4, 5. But how many class boundaries do we have? 1, 2, 3, 4, 5. You have 6 class boundaries. So is that always true that if you only have 5 classes, you will have 6 class boundaries? If you have 10 classes, do you have 11 class boundaries? Is that always like that? That means 1 extra more. Is that always true? What do you guys think? So if you have 10 classes, you should have 11 of the boundary class. And the answer is yes. So if you have 5 classes, you always have an extra boundary class. So in other words, I'll put it down here. Your class boundaries can be found by taking the upper of the first class plus the lower of your second class divided by 2, and then and so on. So on means you have to keep on doing it. Upper of the second class, add it with the lower of the third class. And a hint for you guys here is if you have 5 classes, you should have 5 plus 1 boundaries. Okay, so you have to have a extra 1 more, in this case 6. Okay, So if you have 6 classes, then you should have 7 boundaries. So 1 extra. Okay. So this is very important. A lot of students have missed the top 5 classes. You have 5 boundaries, but actually you have 6. So that is called the class boundary. So I'm going to give you some examples here so you guys can see what's going on. So we're going to talk about your homework here. So 2.1 homework. Sorry, it's my mail. There you go. So we talk about class boundaries and all the good stuff. It's chapter 2 now. That's it. Chapter 2. So we got frequency. We'll talk about relative frequency later on. Okay, there you go. We can talk about this one. So this question is given us by this table. This is talking about the age when an award was won for like an award. I think it's a Oscar. And these are the range of the years. And this is how many actors or actresses won an Oscar during that time on the age. So identifying the lower class limit. Can someone tell me what is the lower class limit here? Again, by definition, lower class limit is the smallest number of the class. So can someone tell me what is the lower class limit here, starting from what? If you look at this table.
20, 30, 40.
Yep. 20, 30, 40. This is the first number, right? Okay. 40, 50, 60 all the way. Okay. And then the question will ask you what will be your upper class. So what is your upper class in this case?
29.
The one on the end, the nines. Yep. So it will be 29, 39, 49, 59, 69, 79, and 89, right? Or the one at the end. And then the next question is asking identifying the class width. So how do you find the class width? Remember last time I gave you an example. How do you find this is 5?
I thought you said it's given in the question.
But sometimes it does not. If you give you a table, it does not. So how can you look from the table what is your class width?
You count them 1, 2, 3, 4, 5, 6, 7.
You can count them. So from 20 to 29, how many numbers in there?
8. 9.
Count them. 20 to 29, count. 20, 21, 22. How many numbers in there?
That's 9.
I don't see it's 9. Do you count them?
10.
There are 10 numbers. Yes. So there's one way for you to do it is count 20, 21, 22, all the way to 29, that's 10. But what do I tell you about this 5 that I show you? How do you know this is 5 again? Do you remember? Is if you look at this, is the difference between what?
Oh, yeah.
These 2 numbers, right?
No.
Or the next, or these 2 numbers, right? Or these 2 numbers, right? So can you tell me what is the class width in this case?
9.
No. It's the difference between 20 and 30, right?
Okay.
Or 30 and 40, or 29 to 39. So what is the class width in this case?
10.
That is 10. So make sure you know that. So that is the definitions we have here. So the class width that we just talked about is the difference between the 2 consecutive lower class limit or 2 consecutive upper class limit, should be upper class limit in this case. So so what I'm talking about is these 2 numbers, the 2 consecutive. So if you subtract these 2 up, that will be like 50 to 40, or this 2, 39 to 49 is 10. That is your class width. You guys with me here? Questions? Okay, I'll come back with the midpoint. So what is class midpoint? So class midpoint is actually the middle of the class. So what is the meaning of the middle class is you take the lower class and the upper class, you add them up and divide it by 2. So can someone tell me what is the midpoint for this case? 20 to 29. So what you do is you add these two numbers up and divide it by 2. You got your calculator, take it out and start adding. If you don't have one, use your cell phone because these are very basic stuff. So 20 plus 29 divided by 2. What you get?
24.5.
So this is what we call as midpoint. And go for next one, 30 to 39. So 30 plus 39 divided by 2. What do you get? 34.5, right? 40 to 49. What do you get? Casey, what do you got? Oh. What's the midpoint for the next one?
44.5.
Okay, followed by what? So you can tell you do not need to use your calculator here. So you can tell what is the difference between this 24.5, 34.5, 44.5? 10. So what's the next one?
32.
Huh?
54.5.
54.5.
64.5.
64.5 and what?
74.5.
74.5 and 84.5, right? Because you keep on adding 10. So you can tell that they all have increments of 10, 10, 10, 10, 10, 10, right? 29, 39, 49, they're all 10. This is called a class width. Okay. How many classes we have in this table? 1, 2, 3, 4, 5, 6, 7 of them. So how many midpoints? 1, 2, 3, 4, 5, 6, 7 midpoints. Okay. So the next question is asking us is what is the boundary? So as I told you that 1, 2, 3, 4, 5, 6, 7 classes, this one have 1, 2, 3, 4, 5, 6, 7, 8. So it says extra 1, always extra 1 for boundaries. So can someone tell me how you find class boundaries? This black. How do you find this number, this number? This is called a boundary. Let's circle in black.
We add it and divide by 2.
So at what? At which number? If you look at this.
We add 29 plus 30.
Divided by 2, right?
Mm-hmm.
So what you got that when you add these 2 and up and divide by 2? 29.5, right? Now, where do we put 29.5 in this box? The first one, second one, the third one, which one you put? And you add this up and divide by 2. You have to put it on the second one because that is one right before 29 here. So can someone tell me what number is the one right before 29?
Mm-hmm.
Would it be 19.5?
9, yep. So 19 and 20. So you got 9. You are correct. 19.5. So you also figure out there is a pattern, and the pattern here is all going to be increased by what? By 10. So can you tell me what is the next class boundary is beside those two?
39.5.
And you should have, and then you continue, right? 49.5. And how many do we have here, class? There are 7 classes. You should have how many?
8.
8. So so you have to do 8 in this case. You guys all right? Questions? Okay. And the last thing is asking is how many people is in this survey? So like this question, if I ask you, how many students in this survey? So what do I do? If I ask how many people in this survey? You take all the frequency here and what do you do? You add them up. So if you add all this frequency up, this is the how many people in the survey. So can you tell me how many people in this survey that we have? So what do? You take all this frequency and what do? You add it out, right? So take out your calculator and add all this number up. And if you sum all this up, that is your answer in this case. So go ahead, do it in your calculator. How many we have? 86. Is that right?
Yes.
The 86 people here?
I got 85.
It's 85.
85.
Yes.
85.
Again, make sure you know how to add. Very important. With the calculator. So so make sure that so this is the correct answer. Okay. So this is what we call as a frequency distribution. This is where the question provide you a frequency table. How do you read the table? By finding the lower, upper class, class width, class midpoint, class boundary, and how many people are in there. So mostly all the questions, not all, some of the questions have same repeat. You can tell, right? If you know how to do this, you should know how to do this because they are the same thing. They're asking you for lower class, upper class, class width, class midpoint, class boundary, and then figure out how many people in here. So those are the very similar type of questions. Okay. So so this is what we call as your frequency distribution. So there are some notes you need to watch out when you do your frequency distribution. First thing is your classes cannot be overlapped. So what I mean by your classes cannot be overlapped, it means something like this. That means if you have 52, you have to be 53. You cannot have 52 and 52. That means your classes is overlapping. In this case, if you have 52 and 52. Okay. Next, your data value has to belong to one class. So when I collect data, when I ask you how many of you are this height, you guys only raise your hand one time. You cannot raise your hand. I'm 52 inches tall and I'm 58 inches tall. You know what I'm saying? So it means every data that you have only belongs to one class. We will use the same width. That means that they all, in this case, has a width of 5. So we try our best not to use this is 5, then this is 6, and this is 7. It's not very uniform, we call it. And it can be used in quantitative and qualitative data in this case. Okay, so this is that means you can be categorical, quantitative. The next thing we're going to talk about is the relative frequency distribution. So when you have the word relative frequency distribution, what we do here is we change it to become a percent. Okay, we change the frequency to become percent. So how do we change the frequency to become percent? Is you take the frequency and then you divide this by your total and then times with 100. So if you take the frequency divided by total times by 100, this is what we call as percentage frequencies. That means you change it to percent in this case. Okay, like what you did in my first 1.1 homework, you get the percent. So that is called a relative frequency distribution. So you will get some example like that, which will look something like this. So this is the grade in the class, A, B, C, D, F, and this is how many students get A, B, C, D, F in the class. Can you figure out the frequency distribution for this case, the relative frequency for this case? And round in 2 decimal places. So what do you do here, class? You take the frequency divided by the total times 100. So first thing you need to tell me is what is the total frequency we have? So add this all up, right? So what is the total we have in this case?
45.
45. Is it 45?
I got 40.
My bad.
Or again, class, make sure you use your calculator, add it up. So this is 40. So there are 40 in this class. So this is the total in this case is 40, right? So how do you find the relative frequency for get A? Those students who got A in the class. Anyone know how to do it? You take 5 out of what? 40 times 100, right? Anyone know what is that going to be?
12 and a half.
12.5.
Yeah.
You guys know how to do the next one? Same thing, right? 13 divided by what? 40 times 100. You guys got? It's 13 divided by 40 times 100. 32.5, right? So what we are calculating here is called the relative frequency. And then you keep on doing 14, 5 and 3 and all those. The 5 and the 5 will be the same. So this is going to be 12.5 also. Okay. So this is called a relative frequency distribution. Okay. So you just need to change your frequency to become percentage. Questions with this? Anyone? Questions? Again, you do need a calculator to do your work here. The last thing that we talked
I have a
about.
question.
Mhm.
So like for the frequency and class boundary, class midpoint, is that only for continuous, quantitative?
Yes, you are correct. It's only used for continuous.
Okay.
Yep, only used mostly for continuous. That means you have a range of number like this. So if you have your table has a range of numbers like this, then it will you will have lower and upper. But if you have just like just now we did the A, B, C, D in your class, this one we don't have a lower class, upper class, and all the class width and so on. Next, we will talk about what we call as a cumulative. So this is next. We'll talk about. Okay, so we talk about cumulative frequency distribution. What's the meaning when I say cumulative? Cumulative means you sum all the frequencies from that class and all the previous classes. So example for cumulative frequency distribution is you take the frequency distribution and you cumulate it. So the first one we have here is 4, right? So the cumulative we have is 4. And then the next class is you have add 4 and 8, that is 12. And then the next one is you add 4, 8, and 5. So this is what we call cumulative, means you keep on adding the class and the previous. So 4 plus 8 plus 5, I think is 17, right? And then you do 4 plus 8 plus 5 plus 3, or 17 plus 3, 20. And then 4, 8, 5, 3, and 20, which is 22. So this number, 4, 8, 5, 4, 12, 17, 20, this is what we call as the cumulative frequency. Now, when you do a cumulative frequency, your numbers for the your height here, you cannot use 48 to 52, 53 to 57, because it is accumulate. So you start from the lowest to the highest. So when you have such such cumulative, your height is a little bit different from the one that you see on the frequency distribution. So the height for this 4 is starting from, so the height here is going to be 48 to 52. But for 12, it's not 53 to 57, it's actually is 48 to 57. Because the height here, you add 4 and 8 means you already start. That means there are 12 students that are 48 to 57 inches tall. So the cumulative is actually go from the lowest to the highest of the class. Like 17 is going to be from 48 to 62 inches tall. That means there are 17 students for this range of height. And then for 20 is 48 till 67. And then the last one is from 48 till 72. So just want to tell you guys is that when you do a cumulative frequency, your height in this case is always from the smallest, 48 in this case, to the maximum, the upper height, 52, 57, 62, 67, 72, and you have to keep on adding. Okay, so that is what we call as a cumulative frequency distribution, which will be in the next one. I think if we go on to the next example. Nope, we should put the word cumulative on it. They don't have the word. I will talk about more about this. Yep, so this is the cumulative frequency distribution. So what you do is you add. So the first one only have 28. So you have 28 here. The next one is from 39, so it's less than 40. So you just add 28 and 36. So what is 28 plus 36 will be? So you just need to accumulate this fellow. Keep on adding. 28 plus 36, so 64. And then the next one is 64 plus 13, or 28 plus 36 plus 13. That will be 77. And then plus 3 again, then it will be 80. And then plus 4 is 84. And then plus 1, 85, and then plus 1, 86. So this is what we call as a cumulative frequency distribution. Anyone have any questions with the cumulative part? And the last thing we talk about here is normal distribution. So when you talk about normal distribution, means that there are two criteria. One of them is your frequency has to go low, high, and then low. Okay, so your frequency has to be start from low, high to low. Okay, so for us, your frequency. For example, if you look at this, the frequency doesn't start from low, high to low. Well, it's kind of. Then this one go back up. You go 28, 36 go up. 13 go back down, 3 go down, 4 go back up. So it's kind of not low, high, low. So this is not a normal distribution. So a normal distribution usually has the frequency go low, high, low. And the next one is it has to be symmetrical. Symmetrical means it's kind of like a mirror image. Okay. For example, if I want it to be let me just save this for you guys so you guys can refer to this in your notes here. This will be 3, 2.1. So for example, that is uniformly distribution. You have to look at your frequency. Okay, will be like let's say you got 10, 15, 31, 17, and then 9. So this is considered normal. The reason why I say this is considered normal is because your frequency is from 10 and then go up to 15 and then go up to 31 and then drop 17 and then drop to 9. So this is what we call as low, high, low. Okay. And then if you cut at the highest point, which is in this case is 31, you find out that 15 and 17, they are somewhat the same. And then 10 and 9, this is somewhat the same. This is what we call as symmetrical. So symmetrical means that if you cut it in the middle, and then you see the numbers that is before and after that line. If the number is quite the same, in this case, like plus minus 1, 2, 3, mostly plus minus 1, 2, 3, then this is considered symmetrical. So this kind of frequency distribution is considered normal. Okay, so for normal distribution, this is what you're looking for: low, high, low, and symmetrical. And if one of this is no, like this case, we find out that this is not low, high, low. This is not a normal distribution. Okay, So that is the meaning of normal distribution in this case. So there are some questions we'll ask you for normal distribution. Example will be like this one. Do this distribution have a normal distribution? So if you look at the frequency, does it goes from low to high to low?
Yeah.
Do we? Yes. Is that symmetrical? So how do we know symmetrical is you get the 14, the highest one, and then you look the one before it, and the one before it, and the one before it. Are they symmetrical in this case? Is this symmetrical?
Yeah. So
Yeah.
the last one, the one that you showed us, the
Mhm.
10, 15, 31, 17, 9,
Mhm.
that's not symmetrical then because
Okay, I just want to point again is it do not need to be exactly the same number.
okay.
So if
Okay.
you just have a plus minus 3 difference,
Yeah.
like very close,
Okay.
like 10 and 9, very close, 15 and
Mhm.
17, very close. So if they are very close to each other, then it's considered symmetrical for us.
And as long as it shows where it's like the low, where it goes low, low, high, high, and then low, low again.
Yeah, low and then high, high, and then low. Yep.
Could we
Okay.
picture it kind of like on a graph, like it would look symmetrical?
Yep, you can also picture a graph. So 10 is this is 10. And then 15 goes back a little bit up. And then 31 is up. And then 17 is a little bit like this. And then 9 is a little bit. So you can tell this is symmetrical. Although this 2 is not exactly the same number, and this 2 just a little bit off. So this is considered normal. And for this question is also considered normal. The reason why is because it was low, high, low. So it's low and then go to high and then low, and it is symmetrical. And the word is approximately. So that's the reason why that you guys do not know exactly the same, like here 6, 6, 3, 3, and 1, 1. So it can be like what I just showed to you is approximately the same. You guys okay here? Questions? Anyone have any questions? So mostly all the examples I showed to you, they already built you the frequency distribution, right? And then you just give me all the information, give me the lower class, upper class, and all those things. But sometimes I do want you to build a frequency distribution. So how do you do this is they will have to provide you data. So this is easy because they already give you all the data and all the numbers. You just need to tally them. You guys know what's the meaning of tally? Just count how many of these numbers is between 15 to 29, 15 to 20.9. So we got 1, we got 2, we got 3, we got there's only 3, so there is 3 in here. You guys okay here? And then you count 21 to 26.9, how many is in there, and then so on. So this is considered not too difficult because they give you all the information. But what happens if you get something like my example in here? So this is something you will get in my test or my midterm is you got all these numbers. So pay attention. And there are 24 nicotine amounts here. And they want you to construct a frequency distribution. Start with the lower class limit of 1 milligram, and the class width is 0.2. So what happened is, this is something I will point to you guys since it's in your coming up in your test. So they want you to start at 1 milligram. Don't forget, you have to give me the context. Don't start with 1.0 and so on. You have to tell me what is this 1117, what are all this? These are actually is your nicotine amount. So that is your context. So this is very important. You have to have nicotine and you need to have frequency. And you can short form this if you want to, FREQ or something else. So it says that you start from 1. Now, can you tell me by looking at all this data, which one is the highest? What number here is the highest number? Because then we know where to stop. So the data shows what? 1.8 is the highest one, right? And the question says you have to use the class width of 0.2. So what you do here is you start with 1. So can someone tell me what is 1 plus 1.2? 1 plus 0.1. 1 plus 0.2 is 1.2, right? So if you add these two together, 1 plus 0.2, you get 1.2. Now, where do we put 1.2 at? Do you put it next to this one or below the 1? So should we just say this is to 1.2 like this? Is this correct? Anyone?
I think you should put below it.
You are correct. This is wrong. This is the one that I showed you early on in my, remember I showed you early on that I put cross on it. This is something that a lot of students do in my test. And guess what? If this is wrong, what happens to the rest of all this work? It's all going to be wrong. So don't forget, you have to put it under here. Okay, to get it. And what's the next one? 1 plus 0.2 is 1.2 plus 0.2 again, you get what? 1 point. Anyone? 1.4, right? And what's the next one? 1.0, 1.2, 1.4, 1.6, and 1.8. Are we stopping or are we still continuing? You want to continue? Or this is it?
That is it.
Because your highest is 1.8. So do not continue, put 2.0, 2.2. I will take points off because that's your highest. Can someone tell me what is the number you need to do right before 1.2? What number is before 1.2? What number is before 1.2?
1.1.
1.1. Now I got a lot of students do 1.1999999. Can you do that one? Just pay attention because I got students do this in my test. Can you do 1.19999? Because that's right before 1.2, right? Can you do that? Look at your data. Your data has how many decimal places you see on your data? Your data shows only 1 decimal place. So that means you cannot use so many. So your answer should be just 1.1, 1 decimal place. Okay. So make sure you watch carefully with the data. So your data is 2 decimal place, then you give me 2 decimal place. If data has 1, 1. So don't give me all the 9s then because you will get it wrong. Can someone tell me what is the 1.2 will be? 1.2 to what? 1. What?
1.3.
And then 1.4 till 1.5
5.
and 1.6 till 1.7.
7.
And the last one is 1.8 till 1.9, right? So this is the type. And frequency, you just count how many we have. So we can use like, things that counted, you just scratch it off. So between 1.0 to 1.1, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you just, count them. So that's 13. From 1.2 to 1.3, we got 1, 2, 3, and 4, right? We got 4 of this. You guys with me? This is, again, you need to count them. And then 1.4 to 1.5, we got 1, 2, and 3. So we got 3 here too. And then 1.6 to 1.7, 1, 2, 3. So there are also 3. And then the last one, 1.8 to 1.9, you only got 1. And this is always, I always tell my students to check it, is to add all the frequency. What will be your total is. Go ahead and add all the frequency out. What is your total here? What's 13 plus 4 plus 3 plus 3 plus 1?
24.
24, which is the same as given us in the question. There are how many data in here? There are 24. So if you didn't get 24, that means you miscount or mistally it. Okay. And this is called frequency distribution. What you're doing here is called frequency distribution, okay, which is this fellow that you're talking about. Now the question is asking us to find the class midpoint. Does anyone know how to find the class midpoint? How do you find the class midpoint? Anyone?
You add the upper to the lower divided by 2.
So what? Which? Give me a mid. Which one? What number you add and divide by 2?
Mm-hmm.
Now don't forget, it's a midpoint. It's come from the same class.
So
So-
like, do you add 1.0 or yeah, 1.0
With
plus
with what?
with is it 1.1?
Mm-hmm.
And then we divide by
And
2.
then divide by 2. Yep. So that will give you what? 1.05, right?
Yep.
And then the next one is 1.2 plus 1.3 divided by 2. That will give me 1.25. Then you same thing, 1.4 and 1.5. That will give me 1.45. What do you notice about all these numbers? The midpoint? They all have a difference of what? They all have a difference of 0.2, right? So the next one will be 1.65. And then the next one is 1.85. So this is how you figure out your class midpoint, we call it. So it has to be exactly from the same number. You add up same class, add up by 2. The question is not done yet because we still need to find the class boundary. Okay, now the class boundary. So how do you find a class boundary? A little bit different from the class midpoint. Anyone know how to find the class boundary? Very similar to what we did. What you do? You take the
The upper
upper.
class.
The lower one, add up and divide by 2, right?
Yeah.
So where's 1.1 plus 1.2 divided by 2? 1.15, right?
Mhm.
And I'm doing it on the second one. Why I put it on the second one is because that is one above it. So there is 1.15. So can someone tell me how you calculate the first class boundary? What number is before this 1.1? This is 1.0 to 1. What is number right if you want to go before this? 0.9,
1. Oh,
right?
Oh,
So
yeah.
what is the middle point from between 0.9 and 10? 0.9 and 1.1. Add them up and divide by 2, you get 0. What? Anyone? Calculators? 0.95, right?
yeah.
And again, what is the pattern you see here? The difference between these two is also what? 0.2. So can someone tell me what will be the next class boundary? 0.95, 1.15, 1.35, because they're all 0.2 difference. 1.55, 1.75. Is that correct? Or do we have more? Is this all the numbers we have?
Shouldn't there be one more?
You are correct, because you should have an extra one more, and that should be 1.95. That is correct. So this is your class boundary. So make sure you have 5 here, 5 classes. You should have 6 class boundaries. Okay. So watch out for this. A lot of students make mistake here. You should have 1 extra more. You're correct. And then the question is asking us is, do this appear to have a normal distribution? So usually we don't, so you don't need to talk about that one. So how do we know if it's a normal distribution? It has to be what? Your frequency has to be low, high, low, right? And it has to be symmetrical. So my question is your frequency low, high, low here? Yes or no?
No.
So in this case, is this a normal distribution? This is not a
No.
normal. Yep, it's not a normal distribution. It's not low, high, low. Next, we want you to construct a relative frequency distribution. So in order for me to construct a relative frequency distribution, anyone know what to do with it? You take the frequency divided by the total times 100. So like the first one, which is the nicotine from 1.0 to 1.1, the relative usually is in percent. You have to take 13, because we got 13, divided by the total, which is 24, times 100. So this is very basic calculator. So you can take out your calculator and calculate this. So 13 divided by 24 times 100. So this is around, yep, this is around 54.2. Again, as I told you in my, when you do your online homework, make sure you read the question, how many decimals place you use. But for my test, doesn't matter how many decimal place. And then you keep on doing the next one is 1.2 to 1.3. And then you take the same 4 divided by 24 times 100%. So again, calculator, 4 divided by 24 times 100. So that is around 16.7. Right? So 16.7%. So you do that for these 5 classes. So they got all 5 classes here. So this is how we do the relative frequency distribution. And then the last one we're going to talk about is the cumulative frequency distribution. So in order for us to do the cumulative frequency distribution, you just need to add. Okay, you just need to add. So the first one is 13. And then the next one is 13 plus 4, which is 17. And then the next one is 13 plus 4 plus 3, because those are the 3 that you need to add. So that will be 20. And then the next one is 13 plus 4, that will be 23. And then the last one is add everything, 24. But do not forget that the nicotine that you have here is not going to be the same as 1.1 to 1.1. This is going to be, the first one is the same, 1.0 to 1.1. Then can someone tell me what will be the second one that we use?
Wait, sorry, I have a question.
Mm-hmm.
For the relative percentage one, I thought you said you add frequency divided by the total.
No. You take the frequency
I'm sorry,
divided-
the number of frequency divided by the total, isn't
Mhm.
that like 13, 4, 3? So that would be like 5 divided by 24?
No, this is 13 divided by 24 for the first one. The second one is 4 divided by 24. And the next one will be the 3 divided by 24,
Oh,
because there's 3 on the next one. And then the next one is also 3. So this is relative.
so you take each of them and divide it by,
Yes. Mhm. Each frequency. So you're gonna take
okay,
each frequency.
okay, I didn't understand that part, okay. Each
Yep.
frequency.
Each frequency. Is it better now?
Yes.
And this is the 1 divided by 24. So this is each frequency, but this is cumulate from the previous for cumulative. So, but for the nicotine, you start from 1.0 to 1.1. This one has to be 1.0 to what? 1.3. So just want to tell you that be careful with the nicotine for the cumulative. It's different from the number here. It always start from the least, which is 1.0 in this case, to the highest one, 1.5, to the upper bound here. And then 1.0 to 1.7, and then 1.0 to 1.9. So just want to point out to you guys, these are the few things that you need to watch out when you guys do the cumulative and the relative. Anyone have any questions for me? Anyone? So I'm going to take attendance because time is out here. So please put present in your chat room. So, yep. Attendance, please put present on the chat room here. Yep. Does anyone have any questions for me? I will post this into your into D2L so you know what to do here. Let me finish typing this one out. This is not finished. 1.4 to 1.5. Yep. This one is 1.6 to 1.7. And then this is 1.8 to 1.5. So this is the
notes that I printed
it's a
off.
little bit different, yes.
Okay.
Now we're gonna use this one because this is the one that you will see in your test. The
Okay.
notes the example for this is a bit different because it has a lot of data. So we're not gonna use
Okay.
that. So we're
Okay.
gonna use this one instead of the other one.
Okay.
Yep. So I will post this in D2L so you will get the rest is almost the same, just only the example for this one is different. Yep. Questions, anyone, before we end today's Zoom? So I'm gonna stop sharing here. So don't forget you got 3 homework due on Wednesday, chapter 1, 1, 1, 2, 1, 3. There is no class for my class this coming Wednesday, and we don't have meet on Monday because it's a Labor Day weekend. So I will see you on the following Wednesday, which like 10 days from today. And you do have 2 homeworks due on that Wednesday, which is 2.1 and 2.2. We just did 2.1, the one that we just 2.2. I will show you the old Zoom video, so you might need to watch it on your own. It's a histogram, so it's really straightforward type. So you need to know how to read the histogram. So I think the 2.2 homework is like 6 or 7 questions, very little. So I would recommend you to, if you have any questions in your homework, do send it to me. So I hope you know how to send questions. So every time you do a homework questions, just go under Get More Help and ask my instructor and send me a question. Hey, help me to help. I am stuck here. Can you help me? And hit send, and then I will see it. So every time you guys have any questions, don't be afraid to ask me, and I will reply back to you. So if you have no questions, you may go. If you do have questions, you may stay and ask me. Okay. So I'm gonna start recording.